Hello everyone, welcome to our group project presentation for ECG565 Highway Engineering. We are from Group C EEC 2227A1B.
As our evaluation will look at the sand patch test, which measure pavement macro texture depth. We begin with the condition smooth and dry. We carefully pour a known volume of standardized sand into our cylinder. Brush away the debris from the side. Pour the sand out and spray it into circular patch using a flat disc. Following this, we transition directly to condition smooth and wet. We apply water to stimulate rainy condition on the exact same smooth surface type, repeating the sand distribution to observe how moisture impacts the layout.
We repeated the sand patch procedure on a notably rougher asphalt surface section to compare the macro texture depth value. Under condition 3, rough and dry, the open void of the texture naturally trapped more sand. When we spread the volume out, the circle diameter was significantly smaller than our smooth surface test, indicating a deeper macro texture. Finally, for condition 4, rough and wet, we introduced water to the texture pavement. Spreading the sand on a wet, rough surface requires precision, but it provides vital data on how texture road drain water away from the tire path to prevent hydroplaning.
Our next assessment method utilized the outflow meter. This test determines the water drainage capability of the pavement surface by measuring the time it takes for a known volume of water to escape under a cylinder. For section 05, we position the apparatus on our smooth surface, fill it to the indicated line, release the valve, and carefully time the drainage. On smooth surface, the type metric means water escape at a different rate because there are fewer interconnected surface voids to facilitate quick lateral drainage.
Continuing with the outflow meter evaluation, we shifted the equipment to section 07, our rough surface profile. As expected, the higher macro texture and larger surface voids allow the water to discharge much quicker than it did on the smooth asphalt. This test directly quantifies the drainage performance required for wet rider driving safety, proving that macro texture plays a pivotal role in preventing water accumulation on active roadway.
The final leg of our field testing evaluates macro texture friction using the portable skid resistance tester, commonly known as the British pendulum. We conducted this sweep across 4 distinct scenarios, starting here with section 8 and 9 of the smooth pavement under dry and wet state. The presence of water dramatically changed the friction value, dropping the pendulum resistance reading and highlighting how dangerous smooth road can be during heavy rain due to reduced tire to pavement friction.
Next, we calibrated the pendulum for section 10 and 11 over the rough surface area. The physical aggregate contact provided higher resistance to the rubber slider arm in both states. Even when wet, the coarse texture cuts through the thin water film to maintain grip. Collecting this value helps engineers predict stopping distance and overall road safety parameters across variable weather conditions.
To process this raw data into usable engineering indices, we apply fundamental highway safety equations. For the sand patch test, we calculate the mean texture depth (MTD) using the constant volume of sand divided by the area of our circular patch. MTD equivalent to 4V over 5D squared. For the outflow meter, we compute water discharge per unit length Q using the volume drain divided by the source contact per meter and time. Q equivalent to V over L multiplied by T. These values mathematically translate physical pavement textures into structural drainage flow rates.
When we correlate this calculation, the structural trends are undeniable. Our smooth surface yielded a massive diameter, indicating a very low MTD. Because this closed surface has no drainage voids, its whole water back, resulting in a high discharge time T and lower flow Q. Conversely, the rough surface traps sand within its cavities, producing a small diameter and a high MTD. Those exact same deep microtexture channels allow the water to flush out instantly, maximizing the drainage efficiency of the road surface.
Ultimately, our British Pendulum friction values tie this engineering relationship together. When wet, smooth surfaces experience a drastic drop in DPN because water forms a continuous lubricating film, accelerating hydroplaning risk. Our rough pavement maintain high BPN scores even when wet because its deep texture channels rapidly drain water under pressure, allowing the aggregate tips to break the surface film and maintain tire grip. This proves that high macro-texture depth is absolutely vital for wet weather road safety. That concludes our presentation. Thank you.